For CLO1, I tested my system by checking if the OLED displayed the correct moisture and voltage values, and whether the pump turned on and off based on dry or wet soil. I also tested if the correct voltage values shown on the OLED display were similar to the values shown by the voltmeter in both dry and wet states. I also wrote a unit test for my normalized Y-value method using JUnit. I use it to make sure it correctly converts sensor readings into percentage values. This test ensures that my code is converting values correctly in order to keep data in my graph consistent, and which helped me catch errors early and prove that the code works as expected. For CLO2, I used Fermata 4J API to connect Java to the Arduino and control the hardware. I use classes like I2C device, Fermata device, get pin, set mode, and set value to initialize and control the button, OLED, sensor, and pump. I as well use standard library API to graph the voltage readings in real time. I use methods like stddraw, stdline, and stdtext to build a clean, live updating graph that shows how the moisture level changes over time. For CLO3, I use an array list double to store each voltage reading from the moisture sensor, where each voltage reading is stored in the list every 0.1 seconds. I also added logic to keep only the latest 100 values to make the system efficient and not overwhelm the system with extensive memory. This allowed me to manage the sensor data properly before using it for analysis or visualization. For CLO4, I built an event-driven system using a scheduled task that runs every 500 milliseconds. This task reads the sensor's values, converts the values to voltage, and uses an if statement and a threshold to decide whether to turn the pump on or off. This system also ensures that manual user input is not needed and can run automatically with a provided water source. I also use a pause/resume button on pin D6 that stops the system until toggled again for manual control when the system runs. For CLO5, I used object-oriented programming by creating classes like event, upgrading graph, and value converter, each handling their own responsibilities, and using encapsulation. For example, the event class encapsulates all logic related to reading the sensor, controlling the pump, and updating the OLED display. This made the code easier to test and simpler to update. I also improved my code by avoiding procedural programming and separating different parts into separate classes, making it easier to keep track of and edit. Also, my OLED board would not work wirelessly, so I added an object that was connected to the I2C part of my Arduino board and coded it to bridge the commands from Java to the OLED.